Week 3 practice quiz. So the first question wants us to graph this function y equal 2 absolute value x minus 4 absolute value. Okay? We need to plot at least 5 points. Alright? So the first thing you need to do, guys, is that we need to try to find the vertex of this absolute value function. Alright? The vertex is where all points meet. Okay? Whenever you have an equation, to find your vertex, you need to look on the inside of your absolute value and on the outside, all right? Your vertex is a point, all right? So because of that, we need to get an x and y value. To get the x value, you need to look on the inside of your absolute value. On the inside of my absolute value is a -4. So to get the x value of that vertex, I need to do the opposite of that inside number. Opposite of a -4 is a +4, okay? So now I need to find the y value of that vertex. So to find the y value of your vertex, you need to do the same as the outside number of that vertex. But in this case, is there any number on the right outside of that vertex? Of that equation, I mean? No. So because there's no number on the outside on the right side, we're going to use 0 to represent no number. So we're going to use 0 as that y value of the vertex, okay? So I'm going to go ahead and plot that point. So 4, 0 will be 4 for the x, 0 for the y. So it's on the x-axis, okay? So now I need to find the other 4 points, okay? Because I have 1 of 5, okay? So to find the other 4, I need to look 2 slots to the left of the point and then 2 slots to the right of the point. To the left of this point is a 3 and a 2. So what I'm going to do is that I'm going to plug in 3 and 2 for the x value into my equation to find the y value that goes with them. So what I'm going to do is I'm going to plug these numbers into this equation right here. So I would have 2 absolute value, and I'm going to replace the x with this number right here. I'm going to replace it with 3. Okay, then I rewrite everything else. I rewrite the -4 and the absolute value. Now I'm going to calculate, okay? So the 2 that's on the outside of the absolute value, I'm going to bring it down. I'm going to calculate inside of the absolute value. 3 minus 4 is -1, all right? The absolute value turns any number inside of it into a positive number. So this -1 will turn into a +1. So now we can multiply 2 times 1 and we get 2. So that means when we plug in 3 for the x value, we got 2 for the y value. Alright? So again, this was the x value, and then this is the y that we got. Okay? So now I'm going to plot that point. Okay? So 3 for the x and +2 for the y. Okay? So now I'm going to plug in 2 into my equation. So I'm going to plug in 2. So I would have 2 absolute value. I'm going to replace the x in the absolute value with now 2. Okay? And I'm going to rewrite everything else. So -4 absolute value. Now I'm going to calculate. So this 2 right here, I'm going to bring it down. 2 minus 4 is -2. The absolute value turns that -2 on the inside into a positive number. Now I can multiply 2 times 2 and I got 4. So that means when the x was 2, the y value that I got that goes with it was 4. So now I can put the 4 right here to make that point. Okay? So now I can plot that point 2, 4. Okay? So what you need to know, guys, is that whenever you have an absolute value function, all the points that are to the left of your vertex mirror on the right side. So that means if I plug in 2 numbers to the right, okay, if I plug in 5 and 6, I should get, when I plug in 5, I should get 2, and when I plug in 6, I should get 4. So let's go ahead and let's try to prove that theory, okay? So again, now I'm going to plug in 2 numbers to the right. So I'm going to plug in 5 and 6. So I'm going to test that theory just to prove it to you guys. So I'm going to go a little fast on this. So I'd have 2 absolute value, 5 then minus 4, absolute value. The 2, I bring it down. 5 minus 4 is 1. The absolute value turns any number into a positive. If it's already positive, it stays as a positive. So 2 times 1 is 2. So as I said, when I plugged in 5, I got 2, which was the same y value that we got right here. Okay? So when I plug in 6, I am going to also get 4. And I'm going to prove it to you. Okay? So I would have 2 absolute value 6 minus 4. Okay? So the 2, I bring it down. 6 minus 4 is 2. The absolute value makes the number stay as a positive. 2 times 2 is 4. So as I said, guys, the point will be symmetric about its vertex. So once you know one side, the numbers to the right should mirror those same y values. Okay? So now I'm going to draw my graph. Okay? So I'm going to connect all my lines together. Start from the top, go through all the points, and then go through all the other points and go all the way back to the top. Alright? So you see how it's facing up? So that the reason why it's facing upwards is because there's a positive number in front. Okay? So let's try the next one. So that's it. Okay? So let's try the next one. So again, first we need to try to find what? The vertex. So first, you need to try to find vertex. Okay? So to find your vertex, you need to look at the numbers on the inside and on the outside of your absolute value. Okay? The number on the inside, you need to remember to do the opposite. Alright? The number on the outside, you do the same. Alright? Opposite of a negative 4 is a positive 4. Opposite of the sign. Same as a positive 4 is a positive 4. So the vertex of this graph right here is 4 for the x and 4 for the y, which is right here. Okay? So now I need to find my other points. Okay? So I need to look at 2 slots to the left and 2 slots to the right. So 2 slots to the left will be 3 and then 2. So what I'm going to plug in is 3 and then 2. So let's go ahead and let's plug that in. 3 and then 2 into my equation for x. So I'm going to rewrite my equation, negative absolute value, and I'm going to replace the x with what number? I'm going to replace it with 3, okay? And then I rewrite everything else, so minus 4, absolute value plus 4, okay? In front of this absolute value is technically a negative how much? 1, all right? And that negative 1, I'm going to bring it down. I'm going to calculate inside of the absolute value. 3 minus 4 is negative 1. Bring down this positive 4 that's on the outside because, again, it's not inside of the absolute value. We have to calculate inside of the absolute value first. So just like when you do PEMDAS, okay? So the negative 1, we're going to bring it down again because the absolute value turns this number inside of it into a positive number, all right? And I bring down that plus 4, okay? So now I can go ahead and multiply these two. Negative 1 times positive 1 is negative 1. And then negative 1 plus 4 is positive 3. So when x was 3, the y value was also 3. So again, when x was 3, the y value was also 3. So I go ahead and plot that point, 3, 3. All right. Now I'm going to plug in 2. I'm going to go a little faster for this one. All right. So I have negative 1, absolute value. Replace the x with 2. Rewrite my minus 4, absolute value plus 4. The negative 1, I bring it down. Calculate. I get negative 2. Bring down that plus 4. Bring down the negative 1 again because the absolute value turns this number into a positive number. Now I multiply. I get negative 2. Negative 2 plus 4 is positive 2. So when I plugged in x as 2, all right, I got 2 as the y. All right. So when I plugged in x as 2, I got 2 as the y. So now I can plot that point, 2 for the x, 2 for the y. Okay? And as I've told you, for the absolute value, all the points to the right should mirror these same y values. So that means that when x was 5, the y would be 3. When x was 6, the y would be on that same line, 2. Okay? and that is what my absolute value function looks like. So I connect all my lines. I start all the way from the bottom, always start at the end of that, go through all the points, and then I'm going to go through all these points and go all the way back down to the bottom. All right. So again, guys, just like that. And you see how this one now is facing down and not facing up? The reason this is facing down is because it has a negative leading coefficient. There's a negative number in front of here, while there was a positive number here. Positive faces up, negative faces down. All right. So let's try another one. Okay. So I'm going to go through this a little faster. Okay. So the vertex. Okay. We get by looking at these points. You do the opposite of this one, and then the same as this number. Opposite of a positive 3 is a negative 3. Same as a positive 5 is a positive 5. We plot that point. Negative 3 for the x, positive 5 for the y. All right. And we know that this one is going to be facing where? Upwards. All right. Because, again, it has a positive number in front of here technically. Okay. So now I look to the left of this point, which is negative 4, negative 3. So those are what I'm going to plug in. All right. So I'm going to plug in negative 4 and negative 3. Okay. Into my equation. So absolute value, replace the x now with negative 4. Okay. And then plus 3, absolute value plus 5, okay? In front of this absolute value is technically a positive 1, so I can bring down that positive 1. Negative 4 plus 3 is negative 1. Then rewrite the plus 5. Then the absolute value turns this number into a positive number, all right? 1 times 1 is 1, and 1 plus 5 is 6. So when x was negative 4, the y would be 6. So I plot that point, negative 4, 6, which is right here. Okay, so now I'm going to plug in negative 3, all right? So I have that same 1, absolute value, replace the x. So again, this was the x, this was the y. So replace the x with negative 3, rewrite everything else. So plus 3, absolute value, plus 5, all right? So now we calculate inside of here, negative 3 plus 3 is 0. All right, so we have absolute value of 0. Okay, but again, when you have the absolute value, just makes the number negative or positive. Because it's 0, I can just eliminate it because 0 is nothing. All right, so that's gone, and I'm just left with the 1. Well, I could have just rewrite as 1 multiplied by 0, and then 1 times 0 is 0. 0 plus 5 is 5. All right, or I could have just canceled it out. Okay, so when the y was negative 3, okay, or sorry, when the x was negative 3, the y was 5. So again, the y for this would be 5. So negative 3, yeah, negative 3. Oh, sorry, we plugged in negative 3. We meant to plug in negative 5. Sorry, not negative 3, because we already plugged in negative 3. We have negative 3, 5 already. All right, so we should have actually plugged in negative 5. Sorry. Okay. So omit that step that I just did a while ago. I should have plugged in negative 5, not negative 3. So I'm going to do that even faster now. All right. Just because I did something that I shouldn't have had to do. So I would have 1 absolute value, negative 5, plus 3 absolute value, plus 5. So we'd have 1, negative 5 plus 3 is negative 2, plus 5. The absolute value turns this number into a positive number. Plus 5, 1 times 2 is 2, and 2 plus 5 is 7. So that means when I plugged in negative 5, I got 7 as the y value. So again, this was the x, this was the y. All right, you didn't need to do this step right here, all right, because we had already gotten this from what our vertex was, all right. So again, we'd have plot negative 5, 7, so negative 5, 7 would be right here. Okay, so that means the numbers to the right of it should be symmetrical. So when I plug in negative 2, I should get the same number as the y value, which was positive 6. When I plug in negative 1, we should get the same number, 7. So start all the way at the top, go through all the points, and then go back all through. All right. So let's do the next questions, guys, real quickly. So it said the quadratic function of f of x is plotted on the graph and the vertex of the resulting parabola is 5, 3. What is the vertex of the function defined as g of x is equal to f of x plus 2 plus 5? Alright, so essentially guys, we need to try to change this point that we are given using this equation. Alright, so to be able to do that guys, you need to remember how to use this general form. So when you see something that looks like this, x plus 2 and a number on the outside at 5, you need to remember that this number changes your x, this number changes your y. But you have to remember to do the opposite of this number. Alright, and then the same as this number. Okay, so essentially guys, if I have the point 5, 3, okay, this number changes the 5, so instead of, it changes the x, so instead of adding 2, I'm going to subtract 2 from my x value. Alright, so if my x value of this, so if I have a 5, 3, and I'm subtracting 2 from here, 5 minus 2 would be 3. Alright, the number on the outside here, you do the same, so I would just add 5, okay, and I would add 5 to this y value, okay, so 3 plus 5 is 8, and that is it, okay. So again guys, remember to do the opposite of this number, same as this number changes the x, this number changes the y, alright. So let's try the next one. So for the next one guys, my point I was given was this, and I need to change it using this right here, okay. So I have f of x minus 2, alright. So there's a number on the inside, I need to do the opposite of that. So instead of subtracting 2, I'm going to add 2 to my x value. Technically, there's no number on the outside. I'm going to use 0 as a placeholder. But can you add or subtract 0, guys? No. Alright? So realistically, your y value is going to stay the same. Alright? So in this case, for my point, -5, -3, all I got to do is just add 2 to my x value. So if I add 2 here, okay, -5 plus 2 is -3. So this will be -3, -3. And that's the answer. Alright, so let's do the last one. So again, we have another quadratic function, which is y equal f of x. We need to transform this point using this equation. So we have f of x and a number on the outside, alright? Because there's no number on the inside, that means your x value will stay the same. So again, normally you do the opposite, but there's no number to do an opposite of that. So that means x stays the same. So x stays the same. Alright? So essentially, the only thing that's going to change is my y value. So I need to do the same as this, alright? So that means all I need to do is subtract 2 from my y value. So my x, my 6 will stay the same, and my y value, my -3, all I have to do is subtract 2 from it, okay? So I would end up having 6, -3 minus 2 is -5. And that is it.